Let's say now we want to determine the domain and range of a function. Take a look at this particular example. In this case, division by 0 is not possible because division by 0 gives an undefined answer. So looking at all the possible values for x to find the domain, we realize that the only number that x cannot be is 2, because 2 will make the denominator 0 and division by 0 is undefined. So we could say that the domain of this function is all real numbers except 2. Now, to find the range for this function, we have to set it up to make the value of x undefined. To do this, we set the function in terms of y so that y equals 1 over x minus 2. Solving for x, x becomes 2 plus 1 over y. Again, the variable lands in the denominator and dividing by 0 is the way to get x undefined. So the range is all real numbers except 0. Now, for this other example, anytime the square root of a function is negative, the domain would not be a natural domain because the square root of a negative number is also undefined. Because the function includes v minus 6, any number less than 6 would make the radical negative. So the domain here is any real number 6 or greater. Now, as far as the range is concerned, again we set up the function and solve for v by saying y equals the square root of v minus 6. Because y is equals to a square root, y may not be negative. Thus, the range of the function is all the non-negative numbers. Okay, by now you get the idea of what a function is and how they are solved. What follows are some more examples of different types of functions, including examples of what is called composition of functions, which is another way of expressing functions within functions, or composite function. Let us see. Find function at b minus 2 if the function of b equals 2b squared plus 1 over b plus 5. Substitute b minus 2 for every b of the function and the function at b minus 2 equals b times b minus 2 squared plus 1 over b minus 2 plus 5. This is the new function. The next expression is called the difference quotient, which is used to explain calculus. In this example, we need to find the difference quotient when the function of x equals x squared plus 5x. To find this function, we need to substitute x plus h into the first part of the numerator of the function so that x squared becomes x plus h squared and 5x becomes 5 times x plus h minus the function of x, which is x squared plus 5x, all of it divided by h, like the original expression. Once the substitution is made, we distribute. We square the binomial and it becomes x squared plus 2xh plus h squared. We now distribute the 5 over xh. 5x plus 5h. We now multiply negative 1 by x squared plus 5x, giving us negative x squared minus 5x. All of it over h. Combine, and the x squares and 5x cancel, leaving behind 2xh plus h squared plus 5h. Factoring the h, we cancel the h in the denominator with a just factored h, and the difference quotient is 2x plus h plus 5.